Hey guys, welcome back to the peer-to-peer network coding session series. This is episode number 11. And what we're going to do today is to make sure that when we are sending a signal onto the network, make sure that we check that the network node is running the trading signal service. Okay, because as of today, the problem is that we are checking only that the HTTP interface is up and running. So that's not enough. Um, so let's go and try to get this goal. So here we have the network node. We will also need the task server. We will need this task server where we are sending the signals into the peer-to-peer network node. So probably the stuff that needs to be upgraded is over here. Okay, so this is the point. Here we have this function called is peer online that sends a test message through the HTTP client, network client. Okay, it sends a test message with this command ping. But the problem is that this test that the network node is responding. But we need to go further than that, and we need the network node to respond as only if the network service trading signals is running. So we have this concept of peer-to-peer network start. What this module does is going to connect, or is going to try to have a list of peers ready to send message to via HTTP. We know that we cannot establish an HTTP connection and keep it open, but we just can test and constantly scan the network to see which nodes are kind of available at least once and running a service. So this auto discovery feature is that we are using in order to have ready a network node with high probability that is going to be responding once it is actually needed, and we don't have to search for it each time we have a signal to send. So my only worry here is that this peer-to-peer network start is really agnostic to the type of service. So maybe here I need to add send message and the network service we want to send this message to. Okay, And if you recall, we have already added the network service as part of the message here. Well, that would say that, okay, so that's one thing. We have it, probably we need this, I don't know. But the thing is that when we initialize this guy, as of today, we have only one network service that can can be accessed via HTTP. Only one. But I can imagine more. For example, if we want to ask a node for statistics, maybe that's publicly available information, and we that would be two services. Maybe there are more later on. So it looks like we will have to upgrade this module to make it multi-network service. Okay. So we will have to run this for a kind of a list of network services. Okay, so I'm going to undo this thing that I did here. And probably the first thing I will do here is I'm going to create an array of network services so that we can, whatever we do, we iterate it. So one is going to be trading signals, okay? And the other network service is going to be stats, just to have more than one. Or network statistics. Let's imagine we have a network service like this. Okay, so when we initialize this, we might want to iterate this guy. This is going to be one individual network service, and we are going to create a function here, realize network service, and receive the network service we want to initialize. So everything we put it inside this function. Okay, and what we're going to do is we're going to run stuff like this. So this function is going to be asynchronic because it have some awaits there, so we will need to await this too. Okay, so this is cool as long as we send a test message specifically for a network service. Okay. Okay. So if it is connected, uh, if it is connected, then we are going to add this to an array, but it's not going to be this array. No, what we are going to do is that we are going to create a map of let peers map. It's going to be a new map. Okay, so when we iterate this guy, we are going to create an array called peers, and we are going to put it at peer map with a key of the name of the network service and the empty array peers. Okay, so now we have peers map. Okay, so we don't have these peers anymore. That means that we don't have this guy, but we have peers map. Okay, so this is already initialized, so we don't need it. Okay, so what we will need, oops, not there, is here. We will say peers is going to be in fact the array by network service. Okay, so it's going to be the empty array, and from there we will use peers as before. Okay, but we know that peer is already stored at that array, and whatever we add there is going to be at that at that map. So that is why it's going to work. Okay, peers, blah blah blah. Okay, that's cool. So here we are, just one peer, and all good. Okay, so this is how we will have an array of peers inside that peers map. But remember that we need to resolve this function well because we send this parameter now. But at this site, who is calling this guy? This guy is calling this guy. So I'm going to put it here. So we were adding this to the message. That means that the message already contains I'm not sure this is the right thing to do. To be honest, I think that this should be sent like here. I want to send this message containing signal to this network service. Okay, so actually this is the problem of peer-to-peer start. When we receive this, now we will have what we used to call the message header. Okay, it's going to be, and here the network service that we receive, we are going to put it inside the message itself. But from here on, we are going to talk about message headers. Okay, so we send a message, blah blah blah. Okay, so and also when we are going to send a message, okay, the message header is the network service is already at the message, so we don't need to pass it as a parameter anymore. But this module might be called from other guys. There is not the signal guy and call some other network service. Okay. Okay, so I don't think that in this case send message anything has to be done because we are sending a message to a peer that we already checked that is supporting this type of network service. Okay, but in this case we will need to check this parameter. We need to pass it forward into here, and we will add this as a second option here, the network service, okay, to the ping that we use to test. Okay, so now we are going to go to the network node here, and network node HTTP interface is here. Okay, so this guy will receive a request. If it is a new message, then the message header will contain, that we already tested this. But if we have a ping, then okay, at request path 2, we will have the network service. Okay, so let network service is going to be the second item on that URL path. So with the network service, what we need to do is something similar to this. A switch by network service would be something we need. Okay, switch by network service. So if it is trading signals, that is the only network service we support so far. And this is not undefined, then we will send this answer. And if not, we will return this error. In fact, it would be better Okay, so this is checking that Pong exists in the answer. And if we are sending this stuff, whatever it says, it doesn't have Pong, so it's not going to work. And it's going to be rejected. That means that if the network service that is not running, then it's not going to be considered a peer we can connect to. Okay? And that's pretty much that's it. So we will not need you anymore. Okay. So let's try it out. Okay, I thought it was going to be longer, but it's not that difficult. So okay, there was something missing here. These object peers. We will need to get the peers like we did before. From the peers map. Okay. And why there is no let here? Let peers equals this. So let peers, we get the peers from the peer maps, and then we have the same array we used to have. Okay. Okay, so I don't see anything else to do. So let's try it out. I will run the network node from here. There is a chance that everything is going to work just like that. So I'm going to take the chance. I'm going to run this directly from Node.js because it just might work. Let's run now. Okay, a little bit slow, but working. So let's run this guy. And let's run this guy. Okay. I see no errors, but I don't see the signals going through either. No errors anywhere. Okay, something not work. This didn't work. No errors anywhere, but things not working, which is bad. So the next thing to try then is to run this task one, but I'm going to need, in order to debug this, I'm going to reduce the simulation So we're going to jump a lot of candles. Let's try this out. So here is running. Debug. This one you can run Node.js. Okay, you can run. But we're going to put a certain breakpoint here. Like here. Hmm. Okay, I'm not seeing. I am not seeing the connection via HTTP. So that's failing. So it's never going to make it through. So I need to check the inner workings of this. We'll debug this stuff. Okay. Okay. Trading signals. Hold on. There is something. What is this? Connect to peers. There will be certain problems because the max outgoing peers setting that I don't really know where this is coming from. This should be per network service, not per total, but it doesn't matter now. Anyways, what is going on here? Hmm. The problem with spaces. That is why this is never coming and is never connecting. So there was a way for removing the spaces or escaping, like unscape. Um, Unscape. So it's either a function of Node.js unscape, or I don't know what it is because there's no definition of this. So probably it is a function of Node.js. So that's what we're needing here. To unscape this guy. Okay, so let's run this again. We will run this guy again. We are already testing this even before running this stuff. Okay, so this would be working. Okay, the guy that was connecting to the network node was this one. Okay, so let's debug this guy. Probably we will let this run. Okay, that means that we got connected and that we can execute this. So where are we? Here. Network service, trading signals. We put this into the message header. We have one node, one peer-to-peer node. That's what we use to continue and send the message. And it was taken by this guy. Okay. So we solve the problem. So we're going to undo our trading simulation changes. And commit this stuff that is checking that signals service is actually running on the network node. Okay, so the only thing that I see that we are missing here is that we are checking this maximum amount of peer to connect to. There are two things that I don't like. One is this parameter, max outgoing peers, that doesn't discriminate between which type of network service we are talking about. Okay, so how do we know how many peers we want to connect to for trading signals or for statistics, for instance? Because it might happen that this might connect to the maximum and then we cannot connect to any of the nodes for the other network service. So this would be per network service, let's say at a minimum. Okay, so that means that but in that way it would work because the peers array is the one that is used to know if we went through the maximum. That means that if we got one peer for trading signals and here maximum is one, then we just get one. We just cannot get more for that network service. But for the next network service, this peers array is going to be empty. So it's okay, that would work. One thing that for sure is not going to work is that we are saving this interval ID into this variable. But the problem with this variable is that when we clear the interval, then we cannot clear the first interval of the first network service because we have overwritten with another interval ID, which is not good. That means that we need one of these for each network service too. So here we will do that this is a new map. And even though this is never clearing because this peer-to-peer network start is never going to be finalized, but the right way to do it anyways is here. Set, and we will use the network service as a key, and here let inter ID. sorry, this goes here. So effectively, we are going to store this map more than one interval ID. So to clear this, we need to do this for each value key any. So for each clear is going to be the function. Here we will receive the value of the map, which is going to be interval ID. And we will do clear interval ID. And after that, we can undefine this. Okay, so we'll make a test to make sure everything was or is still working. For that, I'm going to make back and delete all the data of algorithmic trading, because I'm going to start this. Okay, let's try it again. We're going to start this task and start this task. We'll see both stuff started here. So we are connected via HTTP and via WebSockets to the same network node, number 1 of my user profile. Then I'm going to run this guy. I'm going to run this guy too. So a whole day of signals are going to be produced. And saved and sent through the network and received by this guy and received by this guy. Okay, and executing all the signals, saving, all good. And finally, if we see the charts, both strategies run. Okay, so we are back at the state where everything is working. I'm just going to commit this latest changes on interval ID. Very good. So, to recap a little bit, what we did is that we we finally upgraded this start module, the one that is sending requests via the HTTP interface to a peer-to-peer network node, we upgrade it so that it effectively checks that a certain network service is running before considering that a peer suitable to connect. So we made an upgrade to make it multiple network service. So it's aware of the existence of network services, and the network node is able to respond to a ping request specifically for a network service if it has already instantiated one. And we know that it instantiates once only when it reads at the user profile definition that owns the network service that the network service should be running. So now all the pieces are fitting together. In the next episode, I'm going to move inside the network service trading signals. And there are two options. Maybe I can work on see what is going on there and see how the signals are going to be replicated or sent to other peer nodes, because it's only being sent to the clients that are listening to signals. And another option that I might take is to go back to the infrastructure of permission network nodes and code at the node, implement at the node the verification of permissions for the case that the node is running as part of a permission network node. Okay? So probably I will go that way because it's more low level. I want to have all the low level stuff done so that I have a layer where I can stand and then start building upwards. And like the trading signal is something that is up at least one layer up from that. Okay? So next episode will be about permissions, verifying that whoever is accessing a peer-to-peer network node that is part of a permission network, that even if it is a peer or a client, that has permissions for that network to be at that network. And then I will have to do it at the WebSocket interface and at the HTTP interface. Well, it's going to be fun. So thank you for watching this. See you next time.